What I wanted you to do was to make rectangles with size, for example, not 100, because if they are on 100 pixels distance from one another, and if they are with size 100, they will again be together, just like a one big rectangle. If we have a little bit smaller size for each of them, and if we place them on a slightly bigger distance, for example 100 pixels, they will really look very well and will correctly represent our initial number of lives, which is exactly 5. So I have 5 rectangles now. I can see them. And sadly, I don't lose them, or perhaps this is the best game ever, because I cannot lose any of those lives regardless of how many times I hit the enemy. What I can do now is to create if like this one here, so that the last rectangle will only be drawn if lives left is bigger or equal to 5. Let's see what is happening now. Well, I lost a life. This is great. But the second life that I lost, this was the life which rectangle is drawn at 300. This life is not in an if, so it's always drawn. Well, we can continue copy-pasting ifs like this one. We should be careful to change the condition, because this rectangle should be drawn even if our lives are only 4. So the condition here should be if lives left is bigger or equal to 4. Let's see what's happening now that I lose one life. This was working fine, and now this life disappeared too, but no more lives are going to disappear because I need more ifs here. And I don't want to do them now. This is really horrible and I don't expect you to do it, or perhaps this should be a really small task for your homework. Task 1, add 3 more ifs for the lives in the worst health bar that we did today. I'm telling you that this health bar is the worst because we are about to make a much better health bar that can display not only 3, but for example 30 or 50 lives, and this will not demand 30 or 50 ifs. We will have no more ifs, and we will not have a lot of fill rects. We will have only one fill rect about the health bar, about the lives, but such a fill rect will be executed a lot of times. This is the first time that we are going to learn a knowledge that will let us draw a lot of rectangles, or to execute any other command, not only fill rect, but any command that we decide can be executed a lot of times when we are using the for cycle. For is a little bit similar to if, because it also has curly brackets, and in them we can write as much code as we want. And we also have round brackets, In the round brackets, again, we should write something that will decide when to execute this code. Should we execute it at all, or how many times should we execute it on each occurrence, on each execution of this for? So if we want to learn about for, I'm not going to start talking about it in the draw. I will show you an example on another place. Our code is becoming a little bit bigger, but I want you to focus now on the mouse up code. We will forget for a moment for all the enemies, all the players, all the lives, and we will just experiment with this code. I will print a simple hey message in each execution of the curly brackets, and I will do it for a variable. I will create a new variable now, for example I. This is the first time that I'm creating a variable with a stupid, meaningless name. Most programmers usually use names like this one, but I hate it. I'm doing it now only because I want you to experiment with some pointless code and then delete it from our game. And the pointless code that I'm writing about this pointless variable I is in the round brackets of the for, and you can see that on each mouse up my variable I will start from 0, and while it's less than 10, but 0 is less than 10 and will always be less than 10, so this is kind of stupid, isn't it? While I is less than 10, the code in the curly brackets will be executed. Let's test this. I'm going to go back to my game, and nothing is going on, no haze at all. Is this exactly the opposite from what we expected? I think I expected endless amount of haze. Instead, I don't have any haze at all. Well, in order for this for to be executed, I need to release the left mouse button, and that's what I'm going to do now. Yay! Those were 10 haze. Those aren't 0 haze, so I'm kind of happy. But I expected endless amount of haze, because I, which is 0, will always be less than 10. Or does it? Actually, no. If I is going to increase by 1 on each step, pretty soon it is going to stop being less than 10. You can see what is going on with the variable I. If you add one more console log just like this, and now all those haze are not going to be together, because between each two of them there is going to be a printing of I2. And whoa, this was unexpected. Apparently we got hey 0, hey 1, hey 2, hey 3. And apparently the last one was about I equal to 9. It's time for me to tell you everything about these round brackets of 4. In them we always have to have 2 semicolons that are splitting the place on 3 spots. So I have filled those with I to be equal to 0, I to be also less than 10, and I to be I plus 1. Well, those places have a specific role, and I to be equal to 0 is a line of code that is executed in the beginning, just like it's before the for. I to be equal to I plus 1, or the third thing in our round brackets, is executed after each execution of the curly brackets code. So it's just like it is written on the last line of the curly brackets. And all of this is going to happen while I is less than 10. We can call the three places in our for initial value, condition, and step. And also we got the code in the curly brackets, and there is a really specific order in which everything is executed. I think I told you this order now, but I will repeat it. So first is the initial value, then the condition is checked, and if it's true, we should execute the code in the curly brackets, make a step, and if the condition is still true, the code in the curly brackets, step, and if the condition is still true, we should execute the code in the curly brackets, make a step, and if the condition is still true, execute the code in the curly brackets, make a step. Sometimes the condition will finally become false, and we will no longer execute the code in the curly brackets. We should now skip it and continue after the closing curly bracket, where there is a totally different console log or totally different code. You can see this code finally executed after all of the case and I values. It's pretty interesting what is the value of I now. It's actually such a value that we have exited this for loop. So I is the first value that is not less than 10. We can see what it is. Okay, I is now 10. If I click one more time, you can expect that this loop will not be executed because I is already 10, which is not less than 10. But you're in a mistake, because firstly we should execute the initial value again. Let's see if I'm right about this. I will click now, and yes, I can see everything happening again from here. And all of this can help us in any way with our drawing of a health bar. Well, this is a really interesting task. Of course, we can make here a lot of steps by making a for in the draw tool, and this for can be executed, for example, 5 times. I can also use the variable I here, and it can also start from 0 while it's less than 5 to be increased by 1. I really hope that this is going to draw 5 rectangles now. Let's see. Oh no, I don't see 5 rectangles now. Perhaps I should lose some of my lives, I don't know. Well, no, my lives are now 4 or 3. But I still see them as 1, and even when they are a negative number, they still look like a 1 life. This is kind of normal, because I don't care how much are the lives left currently in this code. I always try to draw them as a 5 lives, but I don't see 5 lives. Why is this for loop not working 5 times? Well, I'm going to tell you why. It is actually working 5 times. It's working perfectly, but the u13 that I have written inside of it is always doing the same thing, and it is drawing a rectangle on 0, 0, meaning the top left corner of the playing field, with the same size. So on each draw I actually draw 5 different rectangles on the same place. This is the reason why I see them as one rectangle. So, is there a way this stupid 4 can help us in any way? I want to see rectangles on different places. How to use a 4 that can have curly brackets executing the same code again and again. How can such a 4 help us have rectangles on different places? Did we have some 4 that we already used in the recent minutes that helped us execute the same code, but the result that we saw in the program is different? Well, actually yes. This is a code that was executed 10 times and it was always the same code, but the results were different. You can see them here. Sometimes we are seeing 0, sometimes 1, sometimes 9. And we can do the same thing with this context point u13. We can change its parameters so that we don't always draw on the same spot. I will give you a hint. I need to change this 0. I don't want to always draw on the x0. I want to draw on different x's. But how to achieve different x's here? Well, one way, the way we used in the mouse up, is by using the counter of our loop, the special variable I, that is changing its values on each step of the for loop. I can write it here too. Let's see what is going to happen. This still looks like a one big life. I'm pretty sad because I assume nothing is going to change now that I lose it. Do you see something changing? Well, nothing should be changed because we are still not using lives left. I'm going to show you where to use lives left if you don't think of this place yourself. Well, I will use lives left here instead of this 5 because I want to see exactly the same number of rectangles as I have lives left. So let's see if we now will be able to see a different number of rectangles according to how many lives do we have. Is there some change here at all? Whoa, did you see this? There is one rectangle visible here, but apparently it is getting small. It's not getting smaller, it disappeared totally. What is going on? I don't understand. Do you understand? Yeah, I understand, but I want you to understand what is happening too. Let's see it again. I have 5 lives now, but they seem like one big rectangle, but this rectangle is getting smaller just like before a lot of time. This rectangle is losing 1 pixel, but in some random moment when our lives become exactly 0, this rectangle disappeared totally. This was not the behavior we have before when we just added 100. This is a totally new behavior, and what is happening is that when lives left is 5, there are 5 rectangles drawn in this 4, and the first rectangle is drawn when I is 0, so it takes the area from x0 to x80. The second rectangle is drawn when I is 1, so it's drawn from x1 to x81. The next is from x2 to x82. The next is drawn from x3 to x83. And the last one is drawn from x4 to x84. Isn't there a fifth life? Well, we counted from 0 to 4, and when I is 5, we don't enter this 4 anymore. So there are actually 5 rectangles drawn, and when lives left is reduced to 4, the last rectangle drawn from 4 to 84 stops being visible. When we lose 1 more life, we don't see the rectangle from x3 to x83, and when we lose all our lives, we stop being able to see even the rectangle from 0 to 80. Then no rectangles are visible anymore, and this is a huge shock for us. But it's not what we needed to code. I don't want all of those 5 rectangles to overlap so much. I want to make the rectangles for life 1, 2, 3 and 4 to be much more to the right. Can you think of a way to draw the second rectangle much more to the right than the first rectangle, which is much more to the right than the rectangle 0? Perhaps it's a solution that I already showed you today. Yes, in order for me to have a big X results, I need to multiply by 100. I'm going to multiply the X on which I draw each of the lives by 100. Let's see if this is working. Well, now I see 5 rectangles and I'm happy, but let's see what is going to happen if I lose 1 or 2 lives. Are you very happy with this? I am. So I want you to try my code now, and you have even more important task now. I want you to write in your sheet of paper with all our knowledge a good explanation for our knowledge that we gained today. I want you to explain that this is an initial value. It's a line of code that is just like written before the for. This is also a line of code, but it's just like it's written before the closing curly bracket. And I want you to explain that this is not a line of code. This is a Boolean expression. It's a condition to be checked, and only when it's true we should execute one more time the curly brackets, the code in the curly brackets. I want you to explain the order of those commands: initial value, condition, and if it's true, code in curly brackets, step, and condition, and if it's still true, code in curly brackets, step, and condition again, and when finally the condition is false, we skip the code in the curly brackets and continue after the closing curly bracket, when there can be a lot of different code to execute. Explain all of this in your sheet of paper, try all my solutions, and then I want you to change lives left to be initially 10. Could this break something? Actually, yes, our health bar will not now stop working because it will not fit in the playing field, and this is a really small change that I want you to fix. I will comment it in the next video. Good luck to you, you have a lot of tasks before the next video.